This relative rate problem is about a melting snowball. A melting snowball has its radius decreasing, I put that in red, at 0.35 centimeter per hour when the radius is 12 centimeter. The question is, how fast is the volume decreasing at that time? So let's write down some givens. So the first thing we know is the radius is decreasing with respect to time. So we have givens. The derivative of radius with respect to time is 0.35 centimeters per hour. Am I missing anything? The answer is yes. Do you see that I put the word decreasing in red? So this is equals to negative because the radius is decreasing and the snowball is melting. So if you are doing homework online, listen to me right now. So I have seen that some textbook use positive 0.35. So if you use positive 0.35, the rate of change of radius will be positive. But the volume is decreasing, right? So the rate should be negative. So if the rate is positive, then you have to add another sentence right next to it saying that the volume is decreasing at that rate. So you will see right in a minute. So I am using negatives. And then what else? When the radius r is equals to 12 centimeters, and I always like to draw a square bracket to box to glue this, so that tells me this is one piece of information and they are looking for the volume, right? So the dv dt, the rate of change of volume, they don't know what it is. All right, so the next question is, should I just plug in 12 to the formula right now? So the volume formula, should I just plug in 12 right now? The answer is no, because volume is changing with respect to time right over here. It is changing with respect to time. If you plug in 12 right now, the derivative becomes a 0. So do not plug in 12 right now because the variable r is changing with respect to time. So the next step is we will be taking derivative of the volume formula using implicit differentiation. So this is a dv dt. I don't recommend using v prime. So this is a 4 over 3 pi, and then using power rule, so we have 3r squared, and then since the radius is changing with respect to time, we have to multiply dr dt, and let me specify this is implicit differentiation. So implicit differentiation. And then what else do we know? So now we are trying to solve for dv dt, right? So we have dv dt equals to, so we have the 3's got cancelled, right? Okay, let's just plug in. So we have a 4 over 3 and then multiply pi. So now we plug in the r. So we have 3 and then r is equals to 12, and then we have a square, and then we plug in the negative 0.35. So that is the only negative quantity. And then back to what I said when we were discussing the given. If you let the dr dt be positive, so do you see that the volume becomes a positive? So I have seen that some textbook, they just use positive, so the answer is going to be positive, and they add another sentence saying the volume is decreasing at that rate. But if you are doing homework online, there is a chance that they only accept positive. So if you use negative, that will be a mistake. So you have to pay attention to this when you do homework online, especially when you are taking exams online, because you will get very limited attempts. All right. So the dv dt, this time we are going to approximate. So you multiply all of this. So this is approximately equals to negative 623.35. So this is cubic centimeters per hour, because this is a volume. So do you see that the rate of change is negative? So that means the volume is decreasing because the snowball is melting, right? Of course, the volume is decreasing. So when we state our conclusion, we say the volume is decreasing at 633.5. I wrote 23, right? So it is supposed to be 33. Okay, 633.35, and then cubic centimeter per hour. So the decreasing covers the negative. When you use the word decreasing, you can take away the negative. So let's add another note. So let's add another note. So if you use dr dt equals to 0.35, then the dv dt is approximately equals to positive 633.35. So make sure you say that this is decreasing. Make sure you add another sentence and say the volume of the snowball is decreasing at that. So when you use the positive, you have to keep one thing in your mind. Okay, so you have to tell yourself that, keep reminding yourself that, okay, that this is a melting snowball, the rate of change of the volume has to be negative. All right, so it has to be negative, and then the volume of the snowball is decreasing. All right, so that is the end of this video. If you like the way I explain related rate, give me a like, share, and a subscribe, and I will see you all in the next related rate problems. Signing out.